Hi everyone, my name is Lou Heander, and today I'm going to do a short form presentation of our research study to design a flexible code block comparison tool in order to improve the code review of refactored code. The method we'd use was the double diamond design process, which is a process focused very much on doing collaborative design. You can read more about it on the Design Council, which has created this model. It has 4 stages: the discover, define, develop, and deliver stages. The first stage, we want to find frustrating parts of the code review, then select which step we want to improve, create an improvement prototype, and finally evaluate the prototype. While discovering frustrating parts of the code review, we did a user group, and here we find 5 main areas that were recurring frustrations. It was diff problems, finding something was new, changed, moved. It was finding similar but unchanged code. As you know, in a code review, only the changed code is there, but if you refactor something or change a function signature, there might be some needed update in unchanged code that isn't there and might cause problems. There's also lack of navigation. In your development environment, you can hover over a function and get its signature, or you can control click and jump to the definition. All of those things are missing in code review. It's also the ordering of files to review. A large feature can be confusing to know where to start. Maybe you want to follow like the call stack order. So many found themselves doing multiple passes, first skimming through the code to get a feel for it, and then reviewing in the order of the function calls. There's also missing overlays and annotations. There is often integration with test systems, like continuous integration, but if something fails, you don't see in the review which test failed. And you also don't see in the review what the code coverage looks like. To create a step to improve, we choose the diff problems. And here we found 4 areas that we wanted to address. The first and most important one was moved code. When you move code within a file or to another file, it often shows up as just one removed block and one added block somewhere else without any way to compare those two and see if there are interline changes. And this makes it hard to know if the code was just moved or moved and changed. It is also a bit hard if you see the removed code block first. It is a bit hard to know if it was actually moved or if it was removed. And also when writing and reading review comments about these moved blocks, the developers cannot see both versions at the same time, and this makes the context a bit difficult. To improve this, we did a collaborative design workshop with active software developers. This was a very lo-fi pen and paper prototype session where we used cut and paste, overhead film, tape to sort of make prototypes for what an interface could look like. From these collaborative design workshop, there also arose some conceptual designs. One was the metaphor of a light board. In analog photography, a light board is a place where you can put the developed raw film and preview it. And then you can like cut out interesting parts, compare frames to each other, that kind of stuff. And we wanted the same metaphor, but for code. So during the code review, you could take a code block and put it on the light board so you could compare it and watch it in more detail later. It was also the concept of matches. That is 2 blocks that can be in completely different parts of the code base, but are automatically detected as similar, and therefore more interesting to do a side-by-side comparison of. With these blocks, either automatic matches or manually put on the light board, you can choose to compare the blocks. And these opens these blocks in like side-to-side comparisons in a modal. And when you're in this modal, there is the action of commenting in that context. So you can read and write comments while in this modal. If you then go back, if you're the author and you get that kind of review comment, you can see exactly the context that the author of the comment was in when they wrote it. With the low fidelity prototypes and the concepts clear, we went ahead and made a high fidelity Figma prototype that implemented this as an extension to the Gerrit code review system. Finally, we tested this prototype on developers, a different set of developers, to get some feedback on how it was working. And overall, it was pretty positive. Participant 3 here, for example, felt like it was a pretty small and subtle change, but that still made a pretty big difference. They didn't need to change their entire workflow or start using a different tool than they were used to. It just improved the experience in the tools and processes they were already working with. Participant 1 agreed. They felt it had a bit of a learning curve, but when you understood how to use it and you got comfortable with putting blocks on the lightboard, sort of saving it for later, they felt it made a really big difference. And also avoided some cut and paste where you sort of like, otherwise they would be working with a meld window, so as third-party comparison tool, and cut paste code into that to make these kind of detailed comparisons. Thank you so much for listening, and the full prototype is available to try on this Figma link, and I will put it in the description as well. And the full paper is also open access, and you can go ahead and read it for more details. See you later.